Okay, everyone. Happy Friday. I hope things are going well for you. A restful weekend is ahead. How are we doing today?
Hi, Paul.
Yeah, same. Pretty universal experience at the moment. Well, let's get moving so that we can get warm and get some sleep. Does that sound fair? Yep. Okay. So, in brief, we've got assignment 1 up here. Please do collect your assessments so that you can see how you did and follow along with any questions that we address there. Overall, everyone did pretty good, but there's a couple of common mistakes that came up that I wanted to at least look at before we move on. Something specific I noticed and was an issue with number 4. So we begin with 5 plus 7 to the third power over 4, then all of that plus x is equal to 8. Our goal is to solve for x. Now, a common first step that I saw periodically was to begin by multiplying both sides by 4. Is that legal here?
Not if you're going backwards.
Well, I suppose technically you can multiply both sides by 4 actually, but what I most often saw when that step was employed is ending up here as a result. So let's say we begin by multiplying both sides by 4, and we end up with this. Is going straight from here to here mathematically correct?
Shouldn't you do the exponent first?
You should. Probably should. The main issue with this step, though, is there's no 4 attached to this x. If you were to multiply one side by 4, you have to multiply everything within that side by 4. There's no divided by 4 here to cancel out. So if one was to do this, you would have to place a 4 there afterwards. And so as a result, this would not be the first step that I personally would make. Do with that information what you will. What I would advise doing, yes, according to order of operations, we should look at the exponents first. So I would recommend looking at 7 to the third power, pressing that down. And I don't actually know that off the top of my head. I lost that page of my work. Plus 7 to the third. 7 to the third turns out to be 343, which is coincidentally the speed of sound in air, so I find that amusing. Divided by 4, plus x equals 8. And then, before we can do this division, 5 plus 343 would be 348 over 4, plus x equals 8. X. 348 divided by 4 is 87 plus x equals 8. And this will then segue to our final answer of negative 79. So, my The reason I bring this up, just as sort of algebra advice, when you say multiply both sides by something, everything within those sides needs to end up in that multiplication. So 4 times all of this at once, that 4 is going to distribute in. That 4 will distribute in. On this term, it'll cancel with this 4, but there's nothing to cancel here. So you can legally mathematically do it, but then you would have a 4x before you move forwards. And then this side would still be 8 times 4. Something to keep in mind. The other thing I just wanted to briefly point out, let's look at 30 as an example of this. In 30, we had 1/5 divided by 5 plus 4 over 1/4. And note how they're written there, so as to make sure it's not 1 divided by 5/5 or 4 over 1 divided by 4. The method most commonly employed that I saw moving forward from this point was to multiply by the inverse to make each of these terms single, whole, not fraction numbers. And when one does that, we're going to end up with 1/5 is the numerator, so that's still here. And what would be the inverse of the 5? It would be another 1/5. And then, here we have 4. I'll write that as 4 over 1. And the inverse of 1/4 would also be 4 over 1. I did occasionally see, instead of, you have to make sure that what is the denominator is clearly defined. The denominator here is just a 5. So the inverse of just 5 is going to be 1/5. And then this will be 1 over 25 plus 16. Final answer is 16.04. So just a couple of observations to help you guys moving forward. That said, everyone did pretty good overall. A's and B's, very happy with things. Make sure all your work is included, because if I don't see the work, it'll be hard for me to look at what you did and figure out how many points your answers are if it's not perfectly correct. It does help if they are roughly in order. It's okay if they're not in order, because I know we jump around ourselves when we're working them in class, which can make ordering them very hard. So what I would recommend doing occasionally, when it's possible, is writing your answers on the front. It helps my grading because I can just see correct, how that one's not totally right. Now let me check the work, whatever page that's on. So that helps me a little bit if it is possible for the assignment. It's not required though, because some questions you can't really do that. But when it's possible, I do appreciate it. Any questions about assignment 1? Okay, yes, sir.
I got 26 wrong, but I'm not exactly sure why.
Mind if I take a look?
You just marked out the numerator, so I wasn't sure what I did.
I try to leave notes.
What is the word?
think I crossed out the numerator since I was looking for a different numerator, but I didn't indicate how to correctly find it. Okay, I see a problem. This is 5 times 3 over 7.
Okay.
So when you multiply them together, all you have to do is multiply 5 by 3. So it should be 15 over 7.
Oh, okay. I don't know where I'm getting this from. I'm like pulling from like, I don't know, middle school, but I don't know why you do that. Like, to get
It resembles how one adds fractions.
Okay, so that one I'm messing up because it's like,
Yes.
not. So if it was 5 plus?
Yes,
Or
5
something
plus
like that?
3 over 7 would be 38 cents.
Okay, all right.
Actually, I did see that issue show up more than once, so let me put that on the board just briefly. Let's look at 26 very quickly. So we're basically adding two fractions with a minor multiplication tacked on there. Let's simplify our terms a little bit. 5 over 10, which everyone can reduce that to 1/2, minus, and now we get to here. We are multiplying 5 by 3/7. And fractions, you can just multiply them as long as they're next to each other. Yes?
I thought that was just like a whole number, this type of fraction. That's like, I got it wrong too, but the only reason I did was because I thought it was just like 5 3/7. I didn't know it was 5 times 3/7.
Oh, so,
That's why I got it.
okay.
Yeah, I think that's why I tried to change it, so it was a mixed number then.
Yeah.
Well, okay. I see where that was coming from then. We don't really do that in physics, which is why I didn't grade it that way.
Yeah, that's okay. Like, I get where it's like, well, I was wrong now, but.
From that context, then that does make sense. So I don't mind taking a second look at it from that lens. But just as a disclaimer then to everybody, in physics math, when you see this, the usual thought is one thing times the other thing. We do not really use mixed fractions around here. I assume most of your science classes wouldn't, but, so disclaimer then, this should be 5 times 3 over 7, which means it should become 15/7. And then the answer, moving on from there, can compress to negative 23 over 14, or about negative 6.4.
Can you explicitly tell us how you want the final answer, like whether it's a fraction or a decimal or whatever, or can we put either?
For this assignment, I accepted either, because I didn't specify.
But on like a test, like you would definitely tell us like what answer, or if you don't, then it wouldn't matter.
Right.
But
Either I will be very clear about what you're supposed to do. If I don't specify, I will grade for any form of the correct answer. Like, on my key, I've got in several places the fraction and then what it's equal to as a decimal number, just for whatever anyone could have written. So if I'm not specific, any answer that is technically that number in any form is correct. Yes?
I don't understand how you got 15 over 7, because wouldn't that just be like a little bit over 2?
That would be a little bit over 2. Yes, it would.
So then how is it 5?
So we're multiplying fractions here. Just going to simplify this as 5 over 1 times 3 over 7. So 5 times 3 over 1 times 7, 15 over 7. 3/7 is a little less than 1/2. Meanwhile, 5 half of 5 is 2.5, so
Okay.
15 over 7 is about 2.5.
Okay. I understand now.
It's okay. Sorry, I lost my train of thought there. Any other questions? Anything at all? Okay. The second assignment, I'm still going to accept next Wednesday, the next class period. If you have any questions about that, do please let me know. I will not be taking the third assignment next Wednesday, as I originally said, because we have not really talked about it yet, and I don't want to collect it at the beginning of Wednesday if I haven't talked about it yet before Friday. So I will probably make the third assignment due sorry. I need my calendar out. Homework 2. Currently due February 17th. Homework 3. I'll make due the week after that. That's the 24th. Those are both Wednesdays. So this is our next class period next week. This is the week after that. And speaking of our third assignment, let's begin working on foiling and troiling. Troil is a trick, well, it's something you've seen before. That word, that term for it, is just something that my previous professor who created this class likes to call triple foiling. I had some questions about that word. So this section is going to be about polynomials and simplifying them, complicating them, and solving for them. A little bit of the quadratic equation in here too. So all about polynomials. Let's take a quick look. Let me rewrite some things. Okay, let's just start by looking at the first question together and describing what it is and what we do with it, what one would do with it. We have open parentheses 5 plus x, close parentheses, open parentheses x minus 3, close parentheses, is equal to 0. Yes?
I never got a homework sheet.
Oh dear, I am terribly sorry. Does anyone else not have an assignment due yet? Okay. Sorry about that.
You're right.
Now, one name for this type of a problem is a polynomial, because ultimately we call it that because poly means multiple and nomial means number. There's more than one correct answer to this question. You've definitely dealt with these before, and in this form, if the goal is to eventually end up with x equals blank, there's 2 correct answers here. Because one thing that would solve this equation is if x was equal to -5. Another thing that would solve it is if x was equal to 3. So 2 correct answers, polynomial. Polynomials can appear in a couple of different forms. This is the simplified version, because looking at this, you can usually tell what the correct 2 numbers are. And if you had a graphing calculator, you were to graph this function, you would see the line form showing those 2 numbers where the line intersects with 0. Now, the other form a polynomial takes is one that resembles, well, let me write the first form first. This is first form. Two sets of x's, each with their own thing being added or subtracted to them. When you multiply the two sets of parentheses together, you'll get 0. This is polynomial form 1. The second form would look something more like this. Familiar? Okay. Another term for this form specifically is a quadratic. You may remember the quadratic formula. We will go over that momentarily. And in this particular form, you have something, some constant a times an x squared, plus something times just an x, and then plus a c term that has no x at all. All that adds up to 0. All polynomials can usually be written in either of these two forms, and they both mean the same thing ultimately. The FOIL technique is how you take form 1 and turn it into form 2. So, as a refresher, FOIL is an acronym that is first, outside, inside, and then last. And how one FOILs a form 1 polynomial is you take the first term here, and then you multiply it. There's a different color name for this. You take the first term, and you basically, we're just multiplying these two things together. We're going to distribute things in, sort of collapse it down into the quadratic version. You take the first term and you multiply it by the lost my train of thought, sorry. Take the first term of the first one, multiply it by the first term of the second one. So I'm going to label that with 1. Then you take that first term of the first one, multiply it by the first term of the second, the second term of the second one. Then third, you're going to take the second term of the first one, multiply it by the first term of the second one, then second term of the first one times the second term of the first one. Sorry, second term of the second one. Which is why I wrote the numbers. We are functionally just distributing one into the other. We are multiplying. And it helps to do them just one piece at a time. So if we're multiplying this into this, let's follow the steps and write it out one piece at a time. First, we have 5 times x, so let's write 5x. Second, we have 5 times negative 3. That will come out as negative 15. So now we've distributed the 5 into both terms. We're done with the 5. We move on to the x. X times x is going to give us x squared. And then x times negative 3 will give us negative 3. All of this is still equal to 0. Now, there's a couple things we can do to simplify this to get to a more compressed final answer. Yes?
Wouldn't it be negative 3x?
Oh, it would. Thank you very much. I'm a human and I make mistakes sometimes. Thank you for catching that, because that would have made things very wrong. So, that's much better now. Of our terms here, 5x minus 15 plus x squared minus 3x, Only 2 of these terms can actually be added together successfully. Which 2 are they? Very good. The 2 terms that only have a single x in them. You've got 5x and negative 3x. Can't be added to something with no x, can't be added to something with 2 x's. So let's compress this, and while we're at it, let's try to put it into this format with the x squared followed by the x followed by the non-x term. The term with the x squared in it is this one. We just have x squared. Next is the term with a single x in it. 2 things fighting for that space are 5x minus 3x. That's going to give us positive 2x. And lastly, our c term is negative 15. All of that equal to 0. I like writing the slash through my zeros to make it clear it's not a capital O. And that is the FOIL version of question 1 and the answer.
So that's all we need to write?
That's all you need to write. If you were asked simply to FOIL something, oh, hold on, we're also asked to solve it. So this is part of the answer. My apologies. But this is the FOIL answer. This is, you were asked to FOIL something, this is what you do, this is what you leave it as. Yes?
So I wrote the top part like on the top of my answer, but then I just setting aside 0.
Come again?
Like I took 5 plus x equals 0 and solved.
Good.
And I didn't know if we could do that because I saw it said FOIL, but I was like, if I didn't, I save treats. I'm just doing 5 plus x equals 0 and x minus 0 equals 0 and solving.
That is part of the question. So that is something that you need to do. So the first section of this assignment asks you to solve and FOIL the following problems. So this is the FOIL solution. This is the half of the question that asks us to FOIL. The solve half asks us to find what x is equal to here. So this is the FOIL, and then for the solve, you need to list what things x should be equal to so that this problem works successfully. What are those 2 numbers? Very good. So how that would normally be written is x equals negative 5, comma, 3. And the question is in this format. Find those numbers by setting just one set of parentheses equal to 0 at a time. So I would do 5 plus x equals 0, x minus 3 equals 0. You can solve each set separately to find one of your x values. And if x is either of these things, then our polynomial equals 0 and everything mathematically checks out. You can even check that these are the solutions by plugging them into your FOIL version. If you put either of these numbers in for x into here, it'll equal 0.
So we
Sorry.
write those 2 things down?
Yes.
For the answer? Okay.
So part 1 of assignment 3 asks you to both solve, so you want to make sure you have x equals blank, and FOIL. So you also want to make sure this is present. For each one, I recommend just boxing each of those answers and then moving on. So solving and foiling. Number 2 is very much a similar type of problem. You do the same thing. 3 is a little more complicated because 3 has another x in it. Now, that just means if there are 3 x's present, that means that there's going to be 3 solutions, 3 things that if x is 0, then the whole thing equals 0. And when you are foiling it, you'll have an extra x to multiply in at the last second. Or he just has that one extra wrinkle on it. Now,
Would you ignore that x first and just do your parentheses?
I would probably do the parentheses first and then the x last, because the x is just by itself. Whatever you have, you then just add an extra x on every term. We can, for the sake of completeness, let's do 2 and 3 together real quick, because that's just good practice for the rest of the assignment. So we'll do 2 and 3, so you have them all in order. For 2, we are given x minus 3 times x plus 4 equals 0. Let's find our solutions first. We'll look at x minus 3 by itself equals 0, and x plus 4 by itself equals 0. So that means that our solutions if x minus 3 equals 0, add 3 to both sides. That's going to give us x equals positive 3. Then x plus 4 equals 0. Subtract 4 from both sides will give us minus 4. So those are the 2 solutions for number 2. So that's the solved portion of 2. Next, we'll FOIL it quickly. X times x is x squared. X times 4 is 4x. So that's the first term twice. Then we have negative 3 times x. And negative 3 times positive 4, negative 12. Oops. We have only one set of terms to compress. That's the 2x terms. So x squared plus just x by itself. 4x minus 3x will just give us 1x. Minus 12 equals 0. And that is the FOIL answer. So that's 2. 3, much the same way. We're just dealing with the one extra x added on the front. So x, open parentheses, 2 plus x, close parentheses, 6 minus x. So the foiling will work exactly the same way. I recommend you do the parentheses terms first, and then distribute the x in after the fact. So your final answer will be of the form blank x to the third plus blank x squared plus blank times x equals 0. The final answer for foiling here will resemble this. It'll be an x third. You'll have an x to the third, that's fine. As for the solving part, we briefly talk about that. We can think of this in a slightly different way, if it helps for the solving portion. Because 0 plus anything is it. Reframe this as x plus 0. It's just a third part to find another solution for. So the solutions here, x plus 0 equals 0. If x is 0, then the answer is 0. So our first solution for that x out front is just 0. Then 2 plus x, subtract 2 to the other side, and we'll get negative 2 as a solution. 6 minus x, in order for this to equal 0, 6 would have to be, sorry, x would have to be positive 6. And those would be the 3 solutions to this one. So the number of solutions is always the number of the, whatever, if you were to FOIL it, and you get to this answer, the number, the biggest exponent present is the number of solutions. How you are doing so far? Yes.
I did it, but I did the, without the 0 first, and then I got my answer, and then I multiplied everything by that. Is that
Okay.
correct?
Yes. That's how I would recommend it, actually.
Like doing the first two and full of those and then multiply, distribute the x.
Yes, I would recommend foiling these two into each other. Then whatever you get from that, when you distribute x in, the number of x's on each term just gets bigger.
And we try not to have a negative in the first exponent, I guess.
I'm not especially bothered by it, frankly, because the negative is always applied to, you can always think of the negative as being part of whatever constant is here. So it can be x cubed times a negative number. That's how I look at it. And that works in the quadratic formula, which I'll talk about briefly in a second, or maybe Wednesday. And so I'm fine if it's a negative out front, doesn't bother me too much. As long as it is, as long as all the numbers are there and correct in the right order, I don't care what's negative, what's positive, as long as it's correct. It can be correct if the first one is negative. If you did want to make it the first one positive, though, you just swap the signs of everything except 0. Okay. 4 and 5 are very similar to this. It says troil, it's a triple foil. So you foil 2 things together, and then you foil that with the third thing. So more distribution, more numbers flying around, but just this with some extra steps. I would like to talk a little more about unfoiling before we break for the weekend, because that is a different thing to do instead of just foiling another time. So we can look at the troiling examples, definitely, but before we break for the weekend, I want to at least look at an unfoiling example. And this assignment refers to unfoiling as the reverse process. We're going from the quadratic form back to the polynomial form. And there isn't, as strictly speaking, a clean method to do it. It's more of a puzzle solving process. So let's take a look at 6. You're given -2 plus x squared equals 0. Now, to do an unfoil, I'm going to list steps. To do an unfoil, the way that I like to do it is, step 1, first thing I do is to put it into the ax squared plus bx plus c equals 0 format. I try to get it into this form first. So reorganize this just a tiny bit. X squared plus x minus 2 equals equals 0. The next step is to find all pairs of numbers that become your C term when multiplied together. Now we put it in this order so that we can tell what our C term is. The C term is the last one that is by itself and has no x in it. So right here, that's going to be -2. So we'll just look at every single combination of things that when multiplied together become -2.
-1.
Yeah, there's only really 2 of them this time. We got -1 times 2 and 1 times -2. So this one's pretty straightforward. There's only there's only 2 combinations of things here. Once we have that list of combinations, step 3 of those combos, find which one find the one where the 2 numbers add together to become the B term. So the B term of our quadratic is just the single x by itself. That means the B is just +1. So we need to pick whichever of these 2 will make, if we add, okay, sorry. So our B term here is +1.
It'd be -1 times 2.
Very good. Looking at these 2 numbers, -1 plus 2 is 1. 1 minus -2 is -1, so that's not our option. That means that these are the 2 things we were looking for the whole time. So this is the version that we have picked. And so now, as we unfoil and continue breaking this thing down, we will arrive at x minus 1 times x plus 2 equals 0. So it's a little more of a puzzle than it is following math steps, but perform this order and you'll get there. And just to double check, if we just sort of mentally refoil this, x times x is x squared, x times 2 is 2x, -1 times x is -1, and -1 times 2 is -2. So we have our -2 in our C, and our B term would be a combination of -x and 2x. They add together to form x. So these are your steps for unfoiling. All of the 6 through 9 section, you'll use those steps to break down your question. And all of those, the A term is a +1, so that helps simplify things. There's one step I left out. It's not an issue on this assignment, because on this assignment, 6 through 10, all of the A terms are already +1. But after getting it in this order, you want to make sure A is +1. If you get things into this format and A isn't +1, you need to divide once or twice to make sure it is before you continue with the rest of this method.
Just divide by that.
You divide by whatever you need to do to cancel out A and make it 1. So just hypothetically, let's say you were dealing with 5x squared. To make A a positive 1, we need to divide everything in this question by 5, which would make everything a nasty fraction to have to deal with, but that's what one would have to do. That isn't going to come up here, but it's worth remembering. We're getting near the end. I don't want to keep you on a Friday. So there's just 2 things that I want to draw to your attention before setting you loose. First is, there is one question on here that does mention the graphing function of your calculator. This document was a PDF. I didn't have time to cut that question out. So not everyone has a graphing calculator. We're omitting graphing questions. So you can go ahead and cross 18 out. Second, a couple of these questions refer to the quadratic formula. So I want to make sure you have that formula. We will use it next time. I just want to go ahead and give it to you to make sure it's in your notes. So we have our quadratic formula. If ax squared plus bx plus c equals 0, you need to make sure this term is 0 before you can continue with the rest of this formula. If this, then x equals, you know what? I'm psyching myself out and I'm worried I'm not remembering it right. So I'm checking real quick. So I have my own notes in my phone. Negative b plus minus square root of b squared minus 4ac. I think there's a song for this. I just never learned. I just don't do it with the song. All of that over 2n. You've probably seen this before. You might use the song. That's great. That's fine. Just making sure it's in your notes. And the plus, just a refresher, the plus minus here means you want to do this twice, once with a plus, once with a minus, so that you get 2 answers, like with the rest of our polynomials. So that is period. If you have any questions at all, please let me know, either now or via email over the weekend. Be working on these. This will not be due next Wednesday. This will be due the Wednesday after that, so we have time to look over things and address them on Wednesday. Excuse me. We'll continue working on this on Wednesday. And do please have a wonderful weekend. Stay healthy and stay dry. It's a wet week. It might be wet. It might be a rainy weekend. Take care. Have a good weekend. You too. Thank you.